Good morning, students. In a previous class of geography, you were taught about the different latitudes and about the longitudes and the grid they form and what are the uses of these particular distributions. We have learned that. In today's class, we will be learning about the motions of Earth. This chapter we will divide it into 4 or 5 different parts because this topic or this chapter, if you will say, is quite lengthy enough to have a 5-part video. Okay, so what I was telling about the motions of Earth. Before coming on to the motion, let us come to one of the most used universal truth. You might have learnt earlier in smaller classes that the sun rises in the east and sets in the west. Okay, so this is the most utilized universal truth in every part of the world, if you will say that the sun rises in the east and sets in the west. So is this true? This is what we are being told when we are taught declarative sentences in English grammar. Okay, so I'm not going on that topic. I just want to utilize this sentence to make you believe what people in ancient time, not very ancient, I must say, just 400 or 500 years back, if you will say, not in our country, because our country has a very modified calculating system of the stars and the planets from a very later time. I must tell and clarify that the Greeks and the Latin peoples, what they thought was this, that Earth is a motionless object and the sky and other celestial bodies revolves and rotates around the Earth. So Earth, they considered Earth as a center object, and then the other celestial body, they move around it. It is being believed that Galileo Galilei was the one to make them believe that this is not true and the Earth isn't still, but the sun is still at one position, and it is Earth which rotates around and revolutes around the sun, and other planets do the same. Before Galileo Galilei, there was one more astronomer, if you will see, in 128 BC, if you will say. He calculated one thing, and what he calculated, I must tell you later in the video. Before coming on that point, let me tell you the Earth, the motions of Earth. Basically, we have learned about 3 types of motion of Earth, that is 2 types of motion, that is the rotation and revolution. Rotation and revolution. Rotation means moving around the axis. Like if I'm standing and I am moving in this way, this is what called rotation. So moving on one particular axis is known as rotation, and revolution means moving around something. For example, if this chalk is the center, or if you are able to see this duster as the center, so and consider this Earth, let me take a bigger piece here. So this consider this piece of chalk as Earth. So what it does, revolution means completing a circle around a particular object. So this is what revolution is known as. Earth rotates and revolutes at the same time. That means Earth, if you are able to see, rotates in this way continuously, and it also circles around the sun while rotating on its axis. So this causes 2 things. First is rotation causes day and night. Every day we wake up in the morning and sleep at night. How does it happen? Because our body is set to a particular clock. Our body has its own clock. You might have heard a word named jet lag. Jet lag is, or jet lag, if you will say that, correct pronunciation will be jet lag. It actually is differences what the body faces when you travel from one time zone to another time zone. That is, if you are traveling from India to a western country which is either behind or ahead of Indian time, your body will feel a kind of disturbance in its system. Like you will be sleeping during the daytime in America and you will be awake during the night time according to America. Your body will need some time, and that particular difference or the particular disturbance, if you will say, is known as jet lag. We are not going to deal more on that. So rotation causes day and night, and revolution causes the appearance of seasons. So why is rotation necessary? For Earth, rotation is necessary because we know that when Earth rotates, it causes day and night. Suppose the Earth was not rotating. I may ask Amit sir, who is sitting behind, to just flash up the torch in his phone and pass it over to me, and I will just show you what would have happened if Earth will not rotate. See, we know that when consider this hand sanitizer as Earth. We know that the sun shines over the Earth, and when it revolutes, if you are able to see, all the parts receive lights equally. Okay, so what would have happened if Earth would not have rotating? The side facing the sun will receive continuous light of the sun, whereas the side which is behind it will not be receiving any sort of light. So the particular side facing the sun, for example, this written area is facing the sunlight, this complete area, it would have been immensely hot, while the backward area would have been extremely cold. So this is what I was making you to understand, that the rotation of Earth is necessary not only for day and night, but to maintain the ideal temperature of the planet. The life is possible on Earth because of many things: its distance from the sun, the favorable conditions, the availability of water, the presence of oxygen. But one thing which we leave behind is the rotation. Rotation is also one of the important features for survival of any thing on Earth. Consider if the Earth was not rotating, as just I have shown you the demo here. If you would have been living in equator, you would have died of extreme heat. Or if you were living somewhere behind the sun, there would have been darkness. I will be telling you in the upcoming videos that what happens when the Earth moves and revolutes, and there are certain things which happens. Now there is a third type of motion which is not necessary for you to understand, but it actually, the Earth also spins. If you might have seen a top means Hindi mein agar kaha jaye to lattu is just a perfect replica of rotating and revoluting Earth. What actually happens, if you will see, Earth and the lattu, it rotates on its axis. Earth has an imaginary axis, and the lattu or the top, it rotates on the nail, if you will see, जिसको कील कहा जाता है, उस पर वो completely rotate होता रहता है. Okay, completely वो rotate होता रहता है. साथ ही साथ it makes a circle. It makes a circle which is kinds of replicates the revolution. There is one more thing which you might have not seen. While rotating and revoluting, it also spins. Matlab a kind of dance you will see that the top does. This is called equinoctial precession. That is not in your course, so we will not be focusing on that, but equinoctial precession is very essential for you for the upcoming classes, because many of the astronomers, they have told that the pole star doesn't change the position, but it changes by some degree, by latest 1 degree or 2 degree. It happens sometimes, but we are not going to focus on that. Just for your information, I was telling you. So we will be focusing on two type of motion, that is rotation and revolution. So rotation is necessary for occurrence of day and night, and revolution is necessary for the appearances of season. Okay, so one final thing in today's video I will be telling you. Earth rotates on an imaginary axis, because anything when it rotates, it has a certain kind of axis. For example, if I am going to rotate this, again the hence let me not take this one, let me take this one. So if I am rotating this piece of chalk, so So the axis which it has, you know, there is nothing like any nail or something here, but still it's rotating. So the axis is between my thumb and the index finger, and a line could be drawn that will be straight here. So that is the imaginary axis of Earth on which the Earth rotates. Okay, and there is also a line, the equinoctial line, on which the Earth revolutes, and it is not perpendicular. Perpendicular means just bisecting it in this way. It is not perpendicular, but it is somewhat in this way, and this angle is 23.5 degrees. That means Earth is not on its axis in this way, but it's tilted in this way. That means the southern part and the northern part remains close to the sun and away to the sun at the same time. I may request Amit sir again to pass me the flashlight so that I can explain you how this actually works. See, Earth is all the time remains in this position. Either this part is close to the sun, it depends on the equinox situation position, or this part. Let us consider this side as southern side and this side as the northern side. So if we are considering this one as northern, this one as southern, and the sun is here, so this part is much closer than that one. So this one will be receiving much of the sunlight than this one, and the day time will be longer here. You might have heard that Antarctica or the southern side have 6-month day and 6-month night, so as the northern side. It happens because of this angle deviation of Earth. Earth is deviated at how many angle? At what angle? 23.5 degree. Okay, so for 6 months this area receive much sunlight comparing to this one, and that's why it's a day here for 6 months and night here for 6 months. After equinox, what happens actually during the time of revolution, it happens, the position of Earth changes in this way. It revolutes in this way, and at one angle, since the sun is still at one position, it comes in this way, and this part receive more sunlight comparing to this one. So this one will have 6 months day, and that will be having 6-month nights, and this one be having summer season here for 6 months and winter here for 6 months. So for today's part, this much will be enough, and you write down what you understood in today's video in the notes column. What we have learned today is about the why rotation is necessary, why revolution is necessary, what is the angle the Earth is deviated at, what is the axis, and why rotation and revolution is necessary. So in the upcoming video, we will be seeing what are the other things in the chapter we shall carry out. Okay, till then, thank you.